Hello dear students, I welcome you to NEET World. So today we will be discussing about the previous year questions of NEET 2020. Okay, so from the NEET 2020 chemistry part we will be discussing today. So in the last session we have discussed 2019 PYQs, right? 2019 NEET PYQs. Okay, so in this session we will be discussing 2020 PYQs. Okay, I hope you have already seen the last session and it will be definitely helpful for your preparation. Okay, so now see, at this moment you need to focus more on these PYQs only, because so when you are solving these PYQ questions, the first thing is you can revise all the topics which are important for the upcoming exam will be revised through the questions. That is one thing, because we'll get to we'll get some habituation towards the exam orientation, I mean towards how we are going to attempt the exam. So see, the question number 40, like 41 may be something like related to, I mean first question may be something related to organic, second may be inorganic, third may be physical, like this. Random questions will be seen from different chapters of chemistry, right? So that time, so your mind has to be jump from here to there, there to another concept like that. So that is what habituation will be happens when you solve the PYQs. Okay, this is one thing. The next thing is you you will get some clarity about your, give me a minute, I think video is not clear. Yes, I hope it is clear now. The next thing is when you solve the PYQs, so when you solve the PYQs, so you will be have some time, time management also. You have to balance the time also. So how much time I should give for botany and zoology and physics and chemistry. So this is what you need to plan. Okay, so do not spend too much time on one particular question. If you are facing really difficult to solve that question, just keep it aside and go to the next question. Okay, so but don't waste the time on one particular question. So this is the next thing you will get when you are attempting the previous year papers. Okay, so let us start our discussion with this question. So I think question is clear, everything is clear. Let me zoom it. Yeah. So what he is saying is the calculated spin only magnetic moment for Cr plus 2. So they have given two things here. Let me take the pen here. Yeah, so they have mentioned here magnetic moment of Cr plus 2. So chromium plus 2. Okay, so what is the atomic number for chromium? It is 24. Okay, so if it is 24, what is the valence electronic configuration we have? So 3d5 4s1. This is the chromium atomic state with oxidation state is 0. So elemental form, this is the electronic configuration. Here it is plus 2. It means we need to remove 2 electrons from here, therefore it will become Cr plus 2. So therefore you can write, when we are removing 2 electrons, so you should write Cr plus 2. The electronic configuration becomes, see, from 4s you are removing 1 electron, from 3d you are removing 1 more electron, so it is 3d4. This is what the electronic configuration for Cr plus 2. Yes. Then next, what is the other thing we have to do? So what is a d orbital, like how can we write it? So draw the orbital diagram like this. So how many electrons are there here? We know there will be 5 d orbitals. So 4 electrons are there here. So put one electron with the same spin in these orbitals by following Hund's rule of maximum multiplicity. Okay, so this is what the electron filling in the orbitals. Now what they are asking, magnetic spin only magnetic moment value. So what is the formula? So mu equals to root over n into n plus 2 Bohr magneton. So where n represents number of unpaired electrons. What is this? Number of unpaired electrons. So here how many unpaired electrons are there here? 4 are there now. So mu equals to root over 4 into 4 plus 2, 6. So this will be root 24 Bohr magnetons. So the value will be nearly equals to 4.90, because root 25 it will be 5, but it is root 24 which is little less than the 5, that is what 25. So we will be getting 4.9 Bohr magneton. I hope it is clear. Okay, there is no confusion. Okay, then let us start discussing the next question. So which are the following is a basic amino acid? So what are the amino acids we know? So here to the alpha, let us say, so this is a carbon. On this carbon we have carboxylic acid. Okay, so this side I am writing here one NH2 group. Okay, so like this we can start, like this is what the generally we will see the amino acid basic structure. It will be having some R groups attached this side, some chain will be there. Okay, so amino acid groups, like amino acids contains one carboxylic functional group and one amine functional group. Okay, if the ratio of carboxylic functional groups and amine groups are same, I mean 1:1 ratio, generally we can say this is what? Neutral. What is this? Neutral I am saying. Now if amine groups are more, then we can consider it is basic, like amine groups are more, so then we can consider that is basic amino acid. If carboxylic acid groups are more, then we can say what? Acidic amino acid. Okay, sometimes some other functional group also might present, or sometimes other functional groups which shows the basic nature also present in this chain, then we can say that is as basic amino acid. So here let us see here alanine. So this is a neutral amino acid now. It contains one carboxylic acid group and one amine group. So here when it comes to lysine, so here lysine contains two NH2 groups. What I am saying? Two NH2 groups and one COOH group. Since the basic groups are more, therefore the amino acid will be basic. So you can choose the option number 4. So it is completely depends completely based on the structures, right? Again, the questions will be like this. So I am only making one question here. This is the second question. So I am making a question for you. Tell me the answer for this question. Okay. So now tell me the most basic amino acid, the most basic amino acid from the, see we have 20 amino acids in the NCERT book now. So out of that, so which is most basic amino acid I am asking. Okay, again similarly I am asking one more question. Let us say what we can say. See, in the last class I told you, in the last PYQ session, 2019 PYQ session, I explained you about what are the essential amino acids, what are the non-essential amino acid also, because there is at least one question from this topic now. So you just tell me that trick I told you there. So to use what are the essential and non-essential. So for essential I told you Hall, Vim, PTT. So this is a code word I told you during the previous session. So this is for essential amino acids. So list out this in the comment box just for revision purpose. So just list out this. What is mean by like H? It is like what? Histidine. I mean what exactly here H? I mean HAL, like lysine, leucine, like this we are writing now. So what exactly all these amino acids? Okay. Similarly for non-essential amino acids I told you AAA, GGG, SPYC is the code word. So this is what we discussed in the last session as a mnemonics, right? So tell me what are these essential amino acids, list in the comment box so that it will be revised for you. Okay, then next. Okay, and the next correct option for the free expansion of an ideal gas under adiabatic condition. So adiabatic condition means what? So exchange of heat does not take place, so dq will be 0, no exchange of heat, right? Between system and surroundings there is no exchange of heat. Okay, so q will be 0, dq will be 0, I can say. Now if there is no exchange of heat, again free expansion. See, free expansion means, let us say this is a container. Okay, so now this container having a piston fitted here, so this piston is like expanding, it means P external will be 0, then the free expansion takes place. Therefore if P external is 0, what is the work done formula? dW equals to minus P external dV. So if P external is 0, the work done will be 0. Okay, so dq 0, dW 0. And then next what about dt they are asking. One more condition is given here. See, dq 0, dW 0. So from first law of thermodynamics we can say du equals to dq plus dW. If dq is 0, dW is 0, I mean dq 0, dW is 0, then du also 0. So this is the extra point I am adding here. Okay, so now here what they are asking about temperature relation. So what is the temperature relation? See, there is no change in the work done, right? There is no change in the heat, so there is no change in the temperature also. Okay, so what are the options here we have? So dt is 0, dW is 0, dt is 0, dw is 0, w is 0, q is also 0. So first option is the most correct. I hope it is clear. dq is 0, so first option it is there, second option it is there, so remaining 2 you can remove. Okay, then next dw is 0, it is there in this first option only, it is not there in the second option, so only first option is correct, like this also. So whatever the concept, whatever the content you know, so based on that you give your approach, so that will be giving you like at least some clarity on the question, at least you can eliminate some options and you can get some clarity, so where you can go for the most correct one. Then next elimination of 2-bromopentane. So pentane means we can write like this 1 2 3 4 5, okay, pentane, so 2-bromo, so here I am taking bromine, this is the 2-bromopentane to form pent-2-ene. So it means from this 2-bromopentane, they are only giving the product also. What is the product he is saying? So remove this, and he is saying this is as pent-2-ene. So pent-2-ene is, this is the pent-2-ene now. So for this purpose, see the internal hydrogen, see this is what the alpha beta elimination. If the halogen attached carbon is called alpha carbon, the adjacent carbons here are beta carbons, right? These are the beta carbons. The hydrogen present on beta carbon will be called beta hydrogen. So alpha beta elimination takes place. From alpha position halogen, from beta position hydrogen as H plus is removed, as eliminated. So when it is eliminating, so we will be getting an alkene like this. So if we use this internal alkene like this inside like beta high carbons, so it will be giving internal alkene. Okay, now if I use this terminal one, so we will be getting some external alkene like this. Okay, so now this kind of elimination takes place, so when the base is normal strong base like KOH in the alkali medium like that. Okay, and the leaving group is good leaving group, then internal alkenes are formed as major product, and we can call them as Sage-Jaffe product. What I am saying, there follows Sage-Jaffe rule. So Sage-Jaffe rule says that internal alkenes are major, and why they are major? Because internal alkenes are more stable than this terminal alkene, which is explained based on the hyperconjugation. I already explained what exactly hyperconjugation. So more the substituted alkene, more is the stability. See here it is less substituted now. So on these carbons, how many groups are substituted? Only one alkyl group is substituted here. But here if we see this side one alkyl group, this side one alkyl group, it means both side it is having hyperconjugations. So that's why this is more stable. Okay, so this is called what? Sage-Jaffe product. Okay, so alpha beta elimination. So in the short form we can say beta elimination also. Okay, so what are the groups removed here? One is hydrogen, one is halogen. Dehydrohalogenation reaction it is. What is that? Dehydrohalogenation. So if they say dehydration, so it means if we remove water, we should call it as dehydration. But here we are removing hydrogen and halogen, so dehydrohalogenation. So A, B, C are correct. So first option is the most suitable one. I hope it is clear, no confusions, right? Okay. Now this product, what is the name of this internal alkene? That is what? Sage-Jaffe product. Sage-Jaffe product. These terminal alkenes are called Hoffman products. What is that? Hoffman product. Okay. So when this Hoffman product is formed, then so whenever this like Br is there na, in that position, if any weak leaving group like fluorine like that, any weak leaving group is present, then Sage-Jaffe product is formed. Or in some cases, instead of using like alkaline like alcoholic KOH or alcoholic NaOH, if they use some bulky base like tertiary butoxide ion, something like this, if they use, then this Sage-Jaffe product is formed. Okay, I hope this Hoffman product is formed. In all other cases, if the leaving group is good leaving group and base is normal strong base in the in alcoholic alcoholic medium, this will be giving Sage-Jaffe product. So this is a story about the elimination reactions. I hope the explanation is very clear. There is no confusion here, right? Next, on electrolysis of dilute sulfuric acid. See, electrolysis process contains two electrodes, one is cathode and anode. So let us say here we have anode and cathode here. So cathode and anode. So anode attracts anions. What are the anions we have? So here I am writing dilute sulfuric acid. So dilute means it is containing water. Okay, so sulfuric acid H2SO4. So in this, what is the anionic part from here? So it will be H plus is cationic form, OH minus anionic form, right? Here I am saying it as H plus and sulfuric acid means sulfate ion I am taking like this. So what are the anions here we have? One is OH minus and other one is sulfate ion. Okay, so both anions are attracted towards anode. The electrode which attracts anions is called anode. Okay, now cathode, the electrode which attracts the cation is called cathode. So what are the cathode like cations? We have H plus. Okay, so both are H plus, so I am writing H plus. Okay, so now here out of these two, OH minus and SO4 sulfate ion, only one anion will be discharged. So this is based upon the electrode discharge theory, like electrochemical series I can say, or preferential discharge theory, based on the preferential discharge theory. So OH minus ion will be discharged first and this will be, so discharge first as OH minus I am writing. So this 4 moles let us say, so it will be forming, it will be releasing O2 gas and H2O is formed. Okay, so 2H2O is formed and releasing 4 electrons. Okay, so this is what happens at anode. At anode again consider oxidation takes place. What happens at anode? Oxidation takes place. See, loss of electron. From here it lost 4 electrons. So this loss of electrons is what? Oxidation process. So which gas is released? O2. So the using electrode, the products obtained at anode will be, what is the product obtained at the anode? So that is oxygen gas and water molecule. Water is not given, only oxygen is given. So without any confusions you can put this second option as the answer. Okay, next at cathode what happens? So these last electrons at anode will be taken by this H plus at the cathode. So if we give 2 electrons for 2 moles, so it will be forming H2 gas. So at anode H2 gas is liberated and here reduction takes place. What happens at cathode? Reduction takes place. So this is what you need to understand. Okay, I hope there is no confusions here. Next, this is done. Next, yes, tell me here. Which of the following is not correct about carbon monoxide? So carbon monoxide, see carbon monoxide when when hemoglobin is see here, which of the following is not correct they are saying now. So it forms carboxyhemoglobin. Okay, so now look here. So we know in the hemoglobin we have central metal atom is iron. So this iron is having more tendency towards carbon monoxide when we compare with the O2. The binding capacity of iron will be more towards carbon monoxide than this O2. Therefore, when a person is exposed to this gas carbon monoxide, so most of the amount of this carbon monoxide is inhaled. So when he is inhaling this CO, so that will be bind with the iron plus 2 of this hemoglobin, and the binding capacity, what I am saying, binding capacity of CO is more than this oxygen. Okay, therefore it will forms carboxyhemoglobin. When CO is inhaled by a person, it will be binding to the iron of this iron metal of this hemoglobin and forms carboxyhemoglobin. I hope it is clear. Okay, the carboxyhemoglobin bound to hemoglobin bound to CO is less stable than the oxyhemoglobin. No, this is more stable. Okay, so that's why binding capacity of CO is more. Okay, so it forms carboxyhemoglobin. This is correct. Okay, it reduces oxygen carrying ability of the blood. Yes. So now what I am saying, when this CO is binding towards this iron, so what there is a percentage of what is the whatever the percentage of oxygen content in the in the body will be decreased because iron is completely binding towards the carbon monoxide. So therefore what happens, ability to carry oxygen will be decreases. So this is also correct statement. First one also correct statement. Okay, the fourth statement, it is produced due to incomplete combustion. Yes, how this carbon monoxide is produced? So that will be produced due to incomplete combustion of some hydrocarbons and any carbon containing species like carbon or any other. Okay, now if we complete if a hydrocarbon is undergoing complete combustion, it will produce CO2. If it is partially undergoing partial combustion or incomplete combustion, it produces CO. I hope it is clear. Carbon monoxide is produced by incomplete combustion. Fourth statement also is also correct. The only third one is incorrect, so you can choose third option. Next, sucrose upon hydrolysis give alpha D glucose, beta D fructose. What I am saying, glucose upon hydrolysis gives alpha D glucose, beta D fructose. Alpha D glucose, beta D fructose. So here we have alpha D glucose, beta D fructose. So option 3 is the correct. Okay. So now the next question will be like this: which of the following is reducing agents, reducing sugars, reducing sugars. Like this they make a question and they will be giving sucrose, and second option something like cellulose, third option lactose, fourth one cellulobiose. So this kind of questions are given in the exam. So identify which is the reducing sugar out of this 4. Okay, so take it as a homework. Hashtag question number 2. So first one I have already given as a homework question in the comment box. You need to answer. So the second one I am giving you. You need to try this. Okay, next CO plus H2. This combination is called synthesis gas. In the short form we can also say syn gas. What is that? Synthesis gas or syn gas. So A3. Next, temporary hardness of water is caused by bicarbonates, calcium and magnesium bicarbonates. B, see A3, B1, A3, B1, C, B2H6 is electron deficient species. So I can say C2, and D, H2O2 is a non-planar having like open book structure we are studying now. So it is having non-planar structure. So D4. So go with these things. So A3, B1, C2, D4. So first option is correct. I hope it is clear. No confusions here. Next, with increase in the concentration of reactants of a reaction leads to change in, yes. Let us say I have a beaker. So in this beaker, first of all let us say 2 mole concentration is there. So 2 mole concentration means what? In 1 liter solution 2 moles of reactants are there. Now I am increasing the concentration to 4 moles, 4 molar. So it means in 1 liter solution number of moles of this particle becoming 4, doubled. So therefore the number of moles, number of particles in the solution, in that solution is more. Now what happens? The collisions will be increases now. In unit volume, for example, initially 2 are there. Now what happens? In the unit volume it will becoming 4. Therefore number of collisions increases, right? So if number of collisions increases, its collision frequency also increases. I hope it is clear. Which of the following is a natural polymer? So cis polybutadiene is what? Okay, wait. Cis polyisoprene. Yes, cis polyiso 1,4 cis polyisoprene. Yeah, we can say this one is a natural polymer. Yes, the next, the rate constant for the first order reaction is, the rate constant is given as K equals to 4.606 into 10 power minus 3 second inverse. Okay, then time required to reduce. See, initially how much it is given? Initially let us say A naught. What is the concentration given? 2 grams. Okay, so after some time t the concentration becoming 0.2 grams. Then the time required to reduce from here to here, like 2 grams becoming 0.2 grams now. So how much time it took for this process they are asking. Since it is saying as first order reaction, what is the formula? T equals to 1 by K ln, see ln concentration, initial concentration by the concentration at time t. This is what we need to consider here, right? Okay. So here T equals to, can I write ln as 2.303 log K A naught. So what is the A naught concentration here? It is given as 2 grams. Okay. And the next AT, how much at time t it is? 0.2 grams. What is the K value they given? So that you can substitute here. How much it is? 4.606 into 10 power minus 3. See here 0.2 and 2. So can I write it as 10 times? Yes. So log 10 will be 1. So what is the remaining thing we have? 2.303 by 4.606. This is 2 times. So can I write 1 by 10 power minus 3 means I am writing it as in the numerator as 1000 by 2 here. So this will be 500. Okay. So what are the units we have? Second inverse. So this will be seconds. So here we have option number 3 as 500 seconds. So this is how you have to solve. I hope it is very easy. So in the last class also, 2019 paper also having same kind of question, similar question, same formula based question. They are asking about T half. So what is a T half? How can we do? And T 99% means how can we do? So this is what given in the last paper. So you can just go through that paper also to understand the concept. Identify the correct statements from the following. CO2 gas is used as a refrigerant for ice cream and frozen food. See, not CO2 gas, it should be CO2 solid. This is what dry ice we will be saying. CO2 solid will be called as dry ice. So this is what used, but it is mentioned gas form. So this is not the correct one. Okay. Next, structure of C60. So C60 fullerenes we are talking now. So they are used as a like nanotubes for cancer therapy and all. Okay. So these C60, like we will be studying them as Buckminster fullerene, right? Like football like structure, like that we will be seeing, right? So this contains, remember, whether it is C60, C70 or C80, whatever it is. So here always remember it contains condensed cyclohexanes and also cyclopentane rings, right? So here always remember cyclopentane rings, cyclopentagons you can say. So like pentagons, it is better to call it as pentagon. Okay. So pentagons are fixed. So in all of these pentagons are 12. How many? Pentagons are 12. That is fixed. Okay. So in C60 the hexagons are 20 hexagons. How many I am saying? 20 hexagon. Okay. I hope it is clear. There is no confusion. Okay. Then next, how can we do this, sir? How can we just having for some clarity here. So hexagons you can find using C by N minus 10. Okay. C by 2 minus 10 we can say. Okay, this is a formula you can use to in order to find number of hexagons. So I will show you for C60 how many carbons are there? 60 carbons are there. 60 by 2 minus 10. See how much here we got? 30 we got. 30 minus 10, 20. So this many number of hexagons are present in C60. I hope it is clear. Similarly, if I ask for C80, how much you will be saying? 80 by 2 minus 10. That's it. C by 2 minus 10 is the number of hexagon rings in a particular fullerene. Okay. So this will be 40 minus 10. So 30 hexagons. 30 hexagons. This is a formula you can remember in order to find number of hexagons. So pentagons are 12. That is fixed in all of this. Okay. So you can tell me what is the answer for C70. Number of hexagons and number of pentagons in C70 you can write in the comment box. Okay. I hope it is clear. No confusions. The structure of C60 contains 12 6-membered rings. 12 6-carbon rings. No. The 12 are for pentagons and 25 carbon ring. So this is reverse now. So that's why. So they are making you to confused. So always remember pentagons are 12, hexagons will vary. So for C60 it is 20 hexagons. I hope it is clear. So therefore this option is incorrect. Okay. GSM-5 is a type of zeolite used for conversion of alcohols into gasoline. Yes, this is correct only now. And CO is colorless, odorless gas. Yes, this is also correct. So what are the options? C and D are correct, which is option number 4. I hope there is no confusion here. Now tell me, which are the following molecule, which are the following set of molecules will have zero dipole moment? So mu should be equals to 0. This is what they are asking us now. So how can we do? Ammonia, what is the structure of ammonia? Like this it will be, right? So it will not be having zero dipole moment now, because the structure will be pyramidal for the ammonia. So the net dipole moment will be upside. So mu net not equals to 0. So this will be this side. So overall will be like top, like upside. So mu net not equals to 0 in ammonia. Okay. So on next, so option 1 is incorrect. So option 2, they are giving it as trifluoride, hydrogen fluoride, carbon dioxide, 1,3 dichlorobenzene. See, look here, hydrogen fluoride, HF. So just look, is this having zero dipole moment? No, because fluorine is high electronegative element than this hydrogen. Therefore, electron movement will be towards fluorine. So polarity is erased, like partial positive charge on hydrogen, negative charge on fluorine. Therefore, mu net not equals to 0 in this case also, not equals to 0. So whatever the compound you are well known of its structure, if you are like whatever the structure you are aware of, take that and identify out of these. So here it is not equals to 0, so then remove this option also. Okay, because should be equals to 0 they are asking, but not equals to 0 here. Next, go through this one also. Nitrogen trifluoride, beryllium difluoride, they are saying again. Boron trifluoride, beryllium difluoride, carbon dioxide, yes. Look here, one more thing, here you can go with option number 3 here, carbon, like benzene 1,3 dichloro, so 1-chloro 3-chloro, 1,3 dichlorobenzene this is. Okay, now see here, whenever we have two similar kind of groups, here electron withdrawing group or releasing group, so what happens here it is, so let us say if it is releasing group, so it will be giving like this, and this group is also giving the electrons into the ring, then this will be giving like this. So net movement will be like this side now. So what is the angle here? Angle is 120 degrees. Okay, so for this mu net is not equals to 0, because see mu net is moving this side. So how can we calculate mu net equals to root over mu1 square plus mu2 square plus 2 mu1 mu2 cos theta, mu1 mu2 cos theta. Okay, so like this we need to calculate. Okay, so here mu net is not equals to 0 in this case, but they are asking about mu net should be equals to 0. So this option is also eliminated. So we have only fourth option. So just write the structures. I will be explaining everything clearly only. Just look here. Carbon boron trifluoride. So it will be like this. So it will be having sp2 hybridization. So look here. This will be this side. This will be this side, and it will be having dipole moment like this. Now the mu net for this bond will be like this. 2 will be like this. So see, they will be having opposite dipoles, they will cancel each other. So mu net will be equals to 0 for trifluoride, boron trifluoride. When it comes to beryllium difluoride, this is also same story. It having linear structure like this, like this. So angle is 180, both are opposite directions, right? Both are opposite directions. So mu net equals to 0 here also. These two are 0. Carbon dioxide applies same story, because it is also having sp hybridization like this. Okay, so this side will cancel out each other, mu net will be equals to 0 here also. Similarly, like 1,4 dichlorobenzene also applies the same story here. So chlorine opposite direction will cancel out each other, and that will be also 0. I hope it is clear. It is clear. So option number 4 is the correct for this. Just try this question. So in the last class also we got the same model question now. So what is the relation we need to use here? Hydrolysis of sucrose in the following reaction is like this. So sucrose upon hydrolysis gives alpha D glucose, beta D fructose, right? Okay. If the equilibrium constant Kc is given at 300 degrees, then delta G naught. So what is the relation between equilibrium constant and delta G naught? That will be minus RT ln K. So this is the relation, delta G and K, equilibrium constant related like this. Just substitute the values or identify it. So just try it. Identify the answer here. So delta G naught equals to minus R value. See, they are given in terms of joules. So you can take 8.314 joule per mole, joule per Kelvin per mole, joule per Kelvin per mole. Like this we can take R value. So what is the T value they mentioned? Temperature is at 300. Yes, you can take 300 Kelvin into, they mentioned in terms of ln only. So you can write ln. What is the K value they mentioned here? 2 into 10 power 13. That's it, done. Okay, ln K, everything is substituted. See here, Kelvin inverse, Kelvin is removed. We are remaining with minus 8.314 for joule per mole into 300 into ln 2 into 10 power 13. So this is the final answer we got, delta G naught value. So identify the similar option here. So here we have first option, yes, yes, yes. So the first option is correct. I hope it is clear, no confusion, right? So even if they ask us to solve, you can simplify this. That will be also like we can do. Yes, this is also one of the important question. This kind of questions you will be seeing in the exam. Okay. Now look here, anisole. What is the structure of anisole? First of all, we should know the structure of the anisole first. So it is very simple. This is a benzene ring. On this you write one methoxy group. This is called anisole. Okay. So now to this we need to add HA. So I already discussed a very clear cut explanation for SN type reaction, nucleophilic substitution reaction. I have provided one of the very quality video of quality lecture on this SN type reactions. So you can go and watch. So once after watching this video, you can able to play with this kind of questions very easily. So in the exam you can do this kind of questions very easily. All the substitution reactions you can do very easily. Okay. See here we have HI now. So this HI is acid, liberates H plus. This H plus is taken by the lone pair electrons of this oxygen. Therefore it is forming what? If this lone pairs take this H plus, it will forms OHCH3 like this, right? Now this is a oxygen with positive charge. Now here what happens is we need to break this bond. Oxygen carbon bond needed to be broken here. But which bond it has to be broken? See, if we break this bond, so what happens? We will be get a phenyl ring with a positive charge, which is unstable. This is highly unstable, I am saying. Okay, one more chance we have. What is the one more chance? I can also break this bond like this, and I am writing the remaining part OH like this. And what is the remaining carbocation? Methyl carbocation. So out of these two carbocations, this methyl carbocation is relatively stable than this like phenyl carbocation. That's why you should not break in this manner. So you have to break the bond in a stable manner like this. If we break here, we will be getting a stable carbocation. So the remaining part will becoming like a phenol, and this on this, what is the negative part here we have? If after removing H plus, we are remaining with iodide ion. So that I minus will be added on this methyl group and resulting to form CH3I. So these are the two things we got. One is phenol and another one is methyl iodide. So phenol, methyl iodide. So first option is correct here. I hope it is clear, no confusion. So for your practice, for I am giving this question for you as a practice question. Look here. So this is also PYQ question. CH2, okay, O like this. Okay, same, giving HI here. Okay, so what is the product formed here? So what is the products formed here? Two types of products is formed. What is the name of A? What is the name of the 3? So this is a hashtag number 3. So where do we need to break this bond? So I told you, you need to break this C and O bond where it generates more stable carbocation. See, if you break this side, we will get a carbocation. Is it stable or the phenyl carbocation is stable? Which one is stable? Break that side and produce the products. Okay, next. Okay, one more model also I just wanted to give here, because this kind of concept we should not skip. Like this they will give, and here they will mention HI. So now what is the product formed here? So now what is the first step? Add this H plus to oxygen. Therefore it generates a like cation, like positive charge on the oxygen. Now what it requires now? Oxygen carbon bond should be breaking of oxygen carbon bond is taking place now. So if we break this side, we will be having a carbocation like this, right? Carbocation like this, right? If we break this side, we will be having a carbocation like this. Okay, so which side the breakage is, after breaking, which species is more stable, this carbocation or this carbocation? We need to consider that. So stability of carbocation we need to consider here. So this is anti-aromatic species now, anti-aromatic, which is highly unstable. Okay, highly unstable. So you should not break in this manner. So if you break here, we are getting stable aromatic species, right? So you need to break this side. Therefore we are getting this carbocation. It means the part will be like this. Product will be, here it will be OH plus, if you are breaking this side, remove this and generate positive charge, on that add this iodide ion, and we will be having a product like this. So this is our product. I hope it is clear, no confusions, right? So I just want answer for this homework question. I given the number as hashtag number 3. Okay, now this is very simple question. Look here, number of protons, neutrons and electrons in this species. So Lu 71, 175. See this number at the bottom. See, if A is an atom, okay, so here this number indicates number of protons, that is what? Atomic number. Okay, here for example, let me take this sign as chi. Chi is a symbol for element, let us say. So Z represent atomic number or number of protons in the given element X. Okay, here I am writing here power this side as A. So this A represents what? Like what? Mass number. So mass number is number of sum of number of protons plus neutrons. Number of protons plus neutrons. Protons are how many? Z number of protons. So protons plus neutrons gives mass number. Okay, so here if we write anything, that will be the charge. If it is cation, write positive charge here, anion, write negative charge there. Okay, so here if we write any number, that represents atomicity. Okay, so in the given question, here they mention it as 21. So number of protons are here, the number mentioned 71. Number of protons are 71, and same number of electrons will also be there in an atom, in an element, in its atomic form. So electrons also 71. Okay, now mass number is given as 175. So this is what? Mass number A equals to number of protons plus neutrons. So now from this we can identify, we can calculate number of neutrons, like number of neutrons equals to A minus P. A is 175, P is 71, therefore number of neutrons will be 104. That is the final answer. Okay, so where do we have like this? 71 protons are 71, electrons are 71, neutrons are 104. Yes, so first option is correct. Next, paper chromatography. Paper chromatography is an example of partition chromatography. What is that? Partition chromatography. Next, this one, identify the incorrect match. See, they will be giving some number following IUPAC nomenclature. For example, we have atomic number 101. So how can we write? By following IUPAC nomenclature. So for 1 we are writing un. Okay, for 0 we are writing nil. Un nil. Again 1. Again un. Un nil un. And the name of this molecule, like element, should end with IUM. Un nil anium. This is the way we need to write the name of this molecule, this element. Okay, so in the short form you can represent U, N, U, un nil anium, like that. Okay, so this is the atomic number of Mendelevium. So what is that? 101 element is Mendelevium. Mendelevium. Okay, so like that A2, like that we need to arrange. So for this, see, I have mentioned here everything, so take a screenshot and try to learn these things. Okay, see, aniline, so what is that? Mendelevium. Okay, so here again 106 they have mentioned in the question, so that is what? Seaborgium. So here just see here anilhexium, so this is C is nothing but this one. Okay, like that. So based on this you have to answer. See, aniltrium, it means an means 1, nil means 0, trium means 3, 103, that is nothing but laryngium, like that. Okay, now here look here, the D option, it is given as an means 1, again an means again 1, again 1 means again an means it should be 1. Okay, last an em. So there is no name like this. Like for 111 we need to, like 11111 we should write it as an em, like this, an em we should write. Okay, but an em, so like this we are writing now. But here Dharm Stadium, just look here, look here, Dharm Stadium is having atomic number as 110, right? So an is this one. So the match for D is incorrect. So match for D is incorrect. So you can go with fourth one is incorrect. D4 is incorrect. They are asking about incorrect one only, no? Like that you can choose. Okay, so try to learn this, and you need to see there are 1 or 2 times asked based on this table itself. Okay, so just go through this table once. Which of the following has maximum number of atoms? So how can we find maximum number of atoms? Just find the number of moles. We know 1 mole means Avogadro number of atoms, no? Okay, that's why we find number of moles. Okay, how can we find given weight? By its atomic weight gives the number of moles. Higher the number of moles, higher will be the number of atoms. Okay, now given weight is same here, 1 gram, 1 gram, 1 gram everywhere. So now number of moles is inversely proportional to atomic weight, let us say. Okay, now the one which is having maximum atomic weight will have minimum number of moles. Okay, the one which is having minimum atomic weight will be having maximum atomic weight. See, out of this all, so D option, I mean fourth option is having minimum atomic weight, therefore maximum number of moles, therefore maximum number of atoms. That's how you need to choose. Option number 4 is correct. I hope it is clear. Minimum atomic weight is for, atomic mass is for lithium. So minimum atomic mass, maximum number of moles, maximum number of atoms. That's why option number 4 is correct here. Next one, the tertiary butyl carbocation. Tertiary butyl carbocation means it should be like this, no? Yeah, so this is a tertiary butyl carbocation, is more stable than the secondary butyl carbocation, which we have learned in the GOC part. This is because of which of the following? Yes, this is because of alkyl groups are plus I groups, and alpha to this carbon, the 3 carbons, this carbocation, the adjacent carbons are called alpha carbons. Okay, hydrogens are alpha hydrogens. So these alpha hydrogens involve in the hyperconjugation with this carbocation. Therefore, how many hyperconjugations are possible here? 3 here, 3 here, 3 here. Total 9 hyperconjugations are possible. So it is stabilized by plus I groups and 9 hyperconjugations. Okay. Now look here, they are mentioned it as minus I group. No, it is incorrect. Plus R effect. There is no mesomeric effect in the alkyl groups like carbocations, like tertiary butyl group. There is no R effect. Okay, there is no R effect. This is also removed. Okay, it means they haven't mentioned it as plus I group, but here they mention it as hyperconjugation. So which is most appropriate answer for this particular question. So you can go with fourth option. Even if they mention along with this plus I group is also mentioned, this is more correct then. Okay, I hope it is clear. Hyperconjugation is one of the major factor which is stabilizing the carbocation here. Next, carbyl amine test. Yes, this carbyl amine test is given by primary amines only. Primary amines, all the primary amines again I am mentioning. See, how can we identify primary amines? Like, see, how we are writing ammonia is this now? Like this we are writing ammonia. So replace one of the hydrogen with R group. Any alkyl groups are aryl group. Then it will be RNH2. Remove hydrogen and replace it with R group like this. Or you can also write aryl ring like benzene ring, like phenyl ring with NH2. Like this also it can be. So on around the nitrogen, one carbon must attach. Only one carbon should be there. So this is called primary. Okay. Now if two sides are like alkyl groups are attached to this nitrogen, so this is tertiary. If three alkyl groups are attached, this is secondary, this is tertiary. Like this we should understand. So only what I am saying, only this primary amines will give. So identify which of these are primary amines. So only first option is primary amine, remaining won't give. Okay, because this is secondary, because two alkyl groups are there, one is aryl group and one is methyl. So that is secondary. This is tertiary, this is again secondary. So this won't give, only primary will give. Just you need to identify primary amine and you can choose that. Okay. Now here I want to make a question for you. So answer this question. See, when a primary amine reacting with chloroform, carbylamine test is primary amines with chloroform. So this forms a compound like this, isocyanates. Okay, so this is what the formed product. So it is having very bad smell, foul smell we can say. So that is the indication, or that is the positive results of this carbylamine test. Okay, now that smell is unable to even to smell it. Okay, now which are the following similar to this, I am making a question here. Which are the following gives positive carbylamine test? Option A like this, B this one, C D yes. So you can tell me out of this A, B, C, D, so which options are giving positive carbylamine test? So take this question number, let us say 4, hashtag number 4. So you can answer by mentioning like this, you can answer in the comment box. I will be waiting for your answer. Okay, which are the following cannot be made in good yield by Wood's reaction? See, Wood's reaction is to make alkanes, higher alkanes like RR kind of products from respective lower alkyl halides. See, for example, we have alkyl halide like this. When we treat this with sodium metal in dry ether, sodium in dry ether, when we treat this, so just remove this XX and take the coupled product like RR kind of product you should get. Okay, RR kind of product. For example, if it is methyl chloride, if we are taking alkyl halides as 2 moles of methyl chloride, so we will be getting, remove this chlorine atom from the two of the sides, so we will be getting ethane as a product like this. Okay, now always see, even you take even number of carbons containing alkyl chain, alkyl halide, or odd number of carbons containing alkyl halide, so it always gives even number of carbons containing product. Okay, so here hexane, which can be prepared from 2 moles of propyl bromide or propyl chloride, something like that, in propyl chloride like that. So here it is 2, 3 dimethyl butane. So 2, 3, yes. So just break here, it means this is the alkyl halide we can take in order to prepare this, right? But when it comes to N-heptane, so we cannot prepare it now properly, because for this here we have odd number of carbons, which means one should be, see, if I want to prepare that, I should take in this manner. See, 1, 2, 3, 4, 5, 6, 6, 7, like this if we say. So it should contain some odd even approach. See, one ring should contains, one chain should contains 4 and other chain should contain 3. It means butyl bromide and propyl bromide gives N-heptane. But when we are taking like cross coupling reaction, so mixture of products will be obtained. But when we are taking only 1 mole of one particular alkyl halide, it purely gives the this coupling product. But here mixture of products are formed which is low in yield, so which is not good yield product. So therefore we can say odd number of carbons containing alkanes are having low productivity in Wood's reaction. So option number 3 is the most appropriate answer for this. So N-butane can be prepared from ethyl bromides or ethyl chlorides. Now, if we take 2 moles of ethyl chloride, it will be giving ethyl plus ethyl. So that is nothing but N-butane, right? Next, this is one of the most important again. In the last class also we have seen which of the following showing positive deviation from Raoult's law, or which of the following are ideal solutions, non-ideal solutions. See, they may ask directly positive deviation from the Raoult's law like this, or they may ask ideal, non-ideal solutions from the following mixtures. They will ask like this, or they will ask third kind of question, azeotropes. Which are the following forms? Maximum boiling azeotropes, minimum boiling azeotropes, maximum, minimum boiling azeotropes. In the last session 2019 question paper we have seen based on the azeotropic mixture, which are the following forming maximum boiling azeotropes, right? Like that they have asked. Okay, so just check that on also. I have explained everything. The positive deviation will be shown by which of these? See, let us say here every time here we have 2 components. Now let us say A is a component in order to make a solution and B is another component. So these 2 components are mixing to form a solution of AB. AB type solution is formed. We know this component A, between AA molecules there will be some interactions, intermolecular forces. Between this BB also some interactions will be there when they are separately taken in the 2 beakers, separate beakers. Now when we are making them to mix, when we are taking them together in a one single beaker like this, okay, when we are taking them into a single beaker, what happens? The intermolecular forces between A and B may be more when we compare with their individual intermolecular forces, or that intermolecular forces may be less than the intermolecular forces of the individual components, right? Okay, based on that we are saying positive deviation, negative deviation. Okay, if the intermolecular forces are more, if for example a acid and a base is mixed, what happens? The acid base will come closer. So when intermolecular forces are more when the mixture when these 2 components are mixed, then what? The solution forms, then solution shows negative deviation. What I am saying, intermolecular forces of these components AB is more when we compare with their individual intermolecular forces, then we can say that shows negative deviation. Okay, now see here ethanol and acetone we have. See, I will be taking this as the best example here, like acetone now. So I am writing acetone formula here, CH3 CH3 CO. This is the acetone. Chloroform will be like this, HCl Cl Cl. Now between this oxygen and this hydrogen there will be hydrogen bond. What I am saying, hydrogen bond. So whenever we are mixing these 2 components, acetone and chloroform, the intermolecular forces are increasing due to the hydrogen bond. Therefore that molecule will come closer. What I am saying, molecules will come closer, and therefore it will shows negative deviation. For example, I am mixing 10 ml of this solution and 10 ml of this solution. So generally what happens, it should form 10 ml of this component and 10 ml of this component. So it should, the resultant solution should contain 20 ml of solution, right? Resultant solution should be 20 ml. But due to this intermolecular forces, the molecules will comes very close. Therefore volume is little bit reduced. It might be lesser than the 20 ml. It may be 19.5, 19.9, 19.99 like that. Because why it is? Because of intermolecular forces. If the volume is less than the ideal mixture, So we can say that is negative deviation. Like this also we can consider. So this will shows negative deviation. Okay. So when the molecules, two components are having like similar nature, chloroethane, bromoethane. So both are halogen attached alkyl groups, both are same alkyl groups. So these are similar kind of products. They will form ideal solution. What this form? Ideal. Okay. So here benzene, toluene, both are having similar nature, na? So this will also form ideal mixture. Ideal mixture. So when ethanol acetone is mixed, so this will form positive deviated solution. So this is shows positive deviation from the ideal Raoult's law. Okay. So the solutions which deviates from the Raoult's law are called as non-ideal solutions. Solutions which obeys the Raoult's law is called ideal solution. So now this mixture will deviates from the ideal from this Raoult's law. So I can say non-ideal solution. Since they are showing positive deviation, we can say this will be the proper answer for this question. Next, reaction between benzaldehyde and acetophenone. So what is this? Benzaldehyde, right? Structure like this, and acetophenone. So acetophenone ring, aceto means this one. Benzaldehyde and acetophenone, dilute base. So this is what? This is what? Aldol condensation between two different compounds here, A and B. It means cross aldol it is. Alpha hydrogens of this will be involved with the reaction of with this oxygen of this benzaldehyde. So I can say cross aldol. Cross aldol. So fourth option is correct. This is based on the ligand field strength of ligands. Okay. So we'll study this in the coordination compounds, right? CFT theories, valency bond theory, those things we'll study now. So the one which is having more strength will be cyanide ion. So C donors are more than, N donors more than, O donors more than halogens. So stronger one is C donor. So here C after N. So first one is cyanide ion will be having maximum strength. Then next oxalate ion. Okay. Then next is SCN. Yes. Cyanide, oxalate, yeah, HCN, then least is halogen. Like this you can choose. So which of the following is cationic detergent? Cationic detergent means, see, we have two types of detergents. One is anionic and the other one is cationic. The head here also the head here you can observe. Okay, if this is having negative charge, we can say anionic detergent. See here, nitrogen, quaternary ammonium salts. So this is the head here. So this will be having positive charge. So I can say this is cationic cationic detergent. What is the name? Like trimethyl ammonium. See, cetyl trimethyl ammonium bromide. So this is a cationic one. Okay, this is sodium laurate sulfate. Sodium laurate sulfate. This is anionic detergent. Anionic. This is cationic. Like this we have to choose. Okay, stearate. This stearate is also what? Negative, anionic one only. Like that we have to look into the structures and decide the answer. Okay. Reaction between acetone and trimethyl, yeah, acetone, very simple questions these are. Acetone with methyl magnesium bromide, methyl CH3 MgBr, methyl magnesium bromide, see CH3 minus Mg plus, right? So this will be attacks on this carbonyl group and generates a CH3 and this new CH3 is coming now. So we can write CH3. So when it is attacking on this electrophilic center, it will be O minus, bond is going upside, pi bond. So this is what? Upon hydrolysis, followed by hydrolysis, so this O minus will becomes OH. So this is what? Tertiary alcohol, tertiary butyl alcohol. 4 carbons are there. So butyl, this is tertiary form, alcoholic form. So option number 3 is correct. I hope it is very clear, right? So now my question is, if I have acetaldehyde with methyl, one equivalent methyl magnesium bromide. So same question with one equivalent methyl magnesium bromide, what is the product formed? Whether it is primary alcohol, secondary alcohol or tertiary alcohol. That is what I am asking. Okay. Next, this is also one of the important question. I mean, concept is important here. Urea. So urea upon heating, this is a formula of urea, reacts with water. Okay, so this will decompose as to give ammonia gas. What it is liberating? Ammonia gas to form A. So this see, decompose to form, wait, urea reacts with water to form A, which will decompose to form B. So this decomposed product is what I am saying, B. So this is what ammonia gas is liberated. So this gas when passed through copper plus 2, so it will forms CuNH3 4 times like this and plus 2. So this complex will be having, see, deep blue, through passed through Cu plus 2, deep blue color solution C is formed. Okay, the formula, what is the formula of C? So this is a formula of C, this is a blue color solution formed. So this is a option number 2 here we have. Number of Faradays, see, the number of Faradays required to produce 20 grams of molten from 20 grams of calcium from molten CaCl2. See, for example, in order to discharge 1 gram equivalent of any substance, we require 1 Faraday of electricity. What I am saying, in order to discharge any substance of 1 gram equivalent, we require 1 Faraday. Okay, so number of gram equivalents GEN is given as N into N factor. So for calcium atom, here it is Ca plus 2 now. So plus 2 to Ca. So this process required how many electrons? 2 electrons now. So N factor here it is 2. How many moles it is given? 20 grams. 20 by its atomic weight is how much for calcium? It will be 40. So it will be 2 times 1. So number of gram equivalents is how many? GEN is 1. So for 1 gram equivalent we require 1 Faraday. That's it. So for 20 grams I can say that is how much it is? 1 gram equivalent. So for 1 Faraday is required. For 1 gram equivalent 1 Faraday is required. Like this you can easily solve. Okay, there are many ways to answer this type of like this concept based question. So this is one of the simplest way I can say. Okay, so now I will be asking you hashtag question number 5. Okay, so number of Faradays required to produce 9 grams of aluminium from its molten AlCl3 from 9 grams of aluminium we should produce from its molten AlCl3. So in order to produce 9 grams, how many Faradays are required here? This is my question. You have to answer in the comment box. Similar to this only. So aluminium, always remember Al plus 3 now. So for conversion of aluminium plus 3 to aluminium, so how many electrons are required? 3. So therefore its N factor is 3. So based on this you can do the further process and tell me the answer in comment box. Now look here, 2 chlorine atoms are there, molecule is forming. So atoms are less stable than the molecule, right? Okay, this is one thing we need to understand. See here, 2 atoms, 2 particles are there becoming 1 molecule, that is 1 particle it is becoming. So atoms becoming molecule, it means number of particles decreasing now. So therefore entropy, disorderness decreases, therefore delta S negative. What happens? Delta S is negative. Okay, this is unstable, this is more stable, therefore from unstable to stable. So during this molecule formation energy is released, so I can say exothermic process, delta H also negative. So this kind of options are delta H negative, delta S negative, delta H, delta S, both are negative, so option 4 is correct. This is one of the most important topic now. Solubility product, KSP and KSP, solubility products, sparingly solubles, all this thing. Okay, so just give a try, I will be explaining. Yes. Now find out the solubility of NiOH twice. So nickel hydroxide is given. So here this is a species is given. Okay. Now when it is like what is the ions we can expect from this? So it will be giving Ni plus 2 plus 2 OH minus, like this, right? Okay. So find out the solubility of NiOH twice in 0.1 molar NaOH. Given ionic product of NiOH is this much. So they given KIP also. How much? 2 into 10 power 15 minus 15 is given. Now let us say this is a concentration, this is a S is the amount of solubility of this particular substance. Initially it will be 0 0 at a time t 0. Okay, after some time T equilibrium, I mean T equilibrium, when we can say some amount of this substance will be dissolved in the water now, soluble in the water now. So after getting solubilized some amount, there exists some equilibrium like this. So that's why I am saying at T equilibrium S minus S alpha, this is S alpha, this will be S alpha. How am I writing this is S alpha? This is the amount which is decrease in the concentration from this substance. So that is converted into its ionic forms like this. Okay, so what is the coefficient here? We have 2, right? So it will be 2s alpha, because 2 ions are coming now, each ion is having s alpha amount. So 2 ions, 2s alpha. Now the dissociation will be 100%. So alpha value here will be 1. So if alpha value is 1, so this becomes s, this becomes 2s, this becomes s minus s, it will be 0, right? I hope it is clear, no confusions, right? So this is in absence of common ion. Okay, so now in presence of common ion what happens? So to equilibrium in presence of common ion. So what happens is the equilibrium, see what do we mean by presence of common ion? So here we are adding NaOH. So NaOH is there now. So we know NaOH is a strong electrolyte. So when we add this NaOH to this equilibrium, the concentration of OH minus ion will be increased. If concentration of OH minus ions is increased, equilibrium will shift backside, because here it is increasing. So equilibrium will has to maintain, therefore it will shift backward. Therefore solubility decreases. Therefore the change in solubility is, let us say, S dash here, and the concentration of this will be 2s plus how much concentration of NaOH we are adding? This is 0.1. The total concentration of OH minus in the solution can be almost equals to the concentration of OH minus ion from the strong electrolyte only. Like this we can write. Okay. Now write this KIP equation. So KIP or KSP here I can say will be equals to concentration of Ni plus 2 into concentration of OH minus, whatever the coefficient is there, write it as a power. Okay, so for Ni plus 2 I am writing S dash into OH minus ion concentration is 0.1 whole square. So what is the KIP value they mentioned? 2 into 10 power minus 15. So if we do this, if we simplify this, what we are getting? S dash equals to 2 into 10 power minus 13. So this will be the final answer. So just check, is there any option of this kind? Yes, 2 into 10 power minus 13 molar. Yes, so this will be the exact answer here. Okay, I hope it is clear, there is no confusion. Okay, so try to focus on this kind of questions. Okay, from solubility you can expect one question again. Okay, the freezing point depression constant, this is from colligative properties solutions chapter. Okay, the freezing point of point depression constant Kf is given, how much? 5.12 Kelvin kg per mole. Okay, next the freezing point depression for the solution of molality is given, 0.078 molality. Okay, containing non-electrolyte solution in benzene. So since it is non-electrolyte, its like 1/2 factor will be 1. Okay, so what is the formula we have for depression in freezing point? Delta Tf equals to IKFM. Okay, so what they are asking? The freezing point of this solution they are asking. So TFS they are asking. Okay, so this is what we need to find. So this is simple now. Here I value will be 1, F value will be 5.2 Kelvin kg per mole into M is how much? 0.078 mole. Okay, molality means mole per kg. So this mole per kg, this kg per mole is removed. So we are remaining with these two things. So if we simplify this, so we will be getting around 0.40 Kelvin. So 0.39, 0.40 we will be getting. So third option is correct. Okay, I hope it is clear, no confusions, right? Next, Cr plus 2. Cr plus 2 is having D4 electronic configuration. They are asking about incorrect statement. Okay, now it is stronger reducing agent than Fe plus 2. Yes, I will agree with this statement because Fe plus 2 is having D6. So when I am saying this is reducing agent, it will reduces others, oxidizes itself. It means it will become Cr plus 3. It means configuration become D3. So D3 means, so in the T2G set we will be having 3 electrons. In the EG set we will be having 0 electrons. Okay, so this is more stable electronic configuration. Whereas D5 will be having for, see, Fe plus 2 means it is having D6. When I say Fe plus 3, upon reducing agent, if we act like this, it will become D5, right? So this D5 will be having T2G2 and EG2 electrons, right? T2G2, 1, 2, 3, EG2 electrons, like this. So this is relatively less stable than this electronic configuration. So all the electrons are present in the lower energy, that is T2G set in chromium plus 3. So which is more stable than this, therefore act as a strong reducing agent. So first option is correct. They are asking about incorrect one. Okay, transition metals and their compounds known for their catalytic activity. Yes, and due to their ability to adopt multiple oxidation state. Yes, and to form complexes. That is also correct. Interstitial compounds are those that formed when small amount of, see, metals will be having some holes, defects will be there. Okay, crystal defects will be there. So due to that some holes will be there. In that the small size hydrogen, carbon, nitrogen gases will be trapped. Okay, so that they can be called as the resulting compound is called interstitial compound. That's it. Okay, next, oxidation state of chromium. This is correct only. They are asking incorrect one. Oxidation state of chromium in this and in this are not same. See here how much it is, x plus 4 into minus 2 equals to minus 2. So x will be minus 2 plus 8. This is plus 6. Oxidation state of chromium in this chromate ion is plus 6. So here also if we do 2x plus 7 oxygen atoms are there, each one is minus 2, overall charge is minus 2. So x will be how much? X will be how much? This will be minus 2 plus 14, it means plus 6 plus 12 and 2. So it will be plus 6. Both are having same, na? But he is saying not same. So this is incorrect. Very easy question. So go through each of the option, then you will get the clarity. Next, which of the following does not exist? See, this is based on the molecular orbital theory. See, I have explained molecular orbital theory very nicely, covering everything related to MOT. And chemical bonding completely I have covered, so that you can go through the playlist of chemical bonding and you can watch. Especially you focus on molecular orbital theory I have made. Okay, from that all the questions which are in the EAPCET and NEET, whatever we can expect, that will be discussed there. So you just go and watch, that will definitely helpful for your preparation. Okay, so in this, so how can you find bond order? You need to find bond order equals to half into number of bonding molecular electrons, BMO electrons, minus ABMO anti-bonding molecular orbital electrons. This is what you need to find. See, for helium 2, helium means hydrogen helium, atomic number is 2. Molecule means total 4 electrons are there. So these 4 electrons should be filled in the molecular orbital. So that is sigma 1s 2 and sigma star 1s 2. See, anti-bonding having 2 electrons, bonding 2 having 2 electrons. Then see, half into bonding molecular orbital electrons 2, anti-bonding also 2. So 2 minus 2, it will be 0 by 2, that will be 0 only. If bond order is 0, that molecule will not exist. Okay, there should be at least some value, like at least 1.5, 1, 2, 2.5, some value should be there, then that molecule may exist. but if it is having 0, that won't exist. So helium won't exist. That's it. That is the correct one. So you can try for this. So then if you try for oxygen, you will be getting bond order as 2 like this. Okay. So everything I explained regarding these things, you can watch the molecular orbital theory, that will be helpful. Okay. So oxo acid of sulfur which contains like peroxy linkage. Yes, this is also one of the important question from oxo acids of sulfur. Similarly, we have oxo acids of phosphorus also. Okay. Next here, how can we draw the structure first? See, there are some trick to do this. See, find the oxidation state of central atom. If the oxidation state of central atom is less than its maximum oxidation state, so direct linkage will be there. If multiple atoms are there, direct linkage will be there, like central atom, between two central atom, direct linkage will be there. If oxidation state of that atom will be equals to its maximum oxidation state, so there will be oxy bond, MOM kind of bond. Okay, here if it may be SO, like SOS type of bond. If calculated oxidation state is greater than maximum oxidation state, then there exist peroxy linkages like this. Okay, so I will be directly going for option number 3 here. Okay, see H2 S2 O8 is given now. So calculate its oxidation state. So 2 sulfurs are there, so 2x, 2 hydrogens are there, 2 into plus 1 plus 8 oxygens minus 2 each, overall molecule is 0, charge is 0, so I am taking like this. So 2x will be plus 16 minus 2, it will be plus 14 and 2x. So x will be plus 7. So oxygen maximum oxidation for sulfur maximum oxidation state should be plus 6. But if we calculate, it is becoming plus 7. That is incorrect now. So it means in that case what I told you, there exist peroxy linkages. So how that peroxy linkage is written? See S you write first. Put one oxygen here and second one here. Similarly this side also. Done. So how many are there? 8 are there. 4 over. Fifth one here, sixth one here, with one hydrogen this side, and here also one, and remaining 2 oxygens are left, write them in between. So now if you calculate, you will be getting 6 plus 6 oxidation state. This is the correct structure. Okay, so this is how you need to understand and analyze the topics, right? I hope it is clear, there is no confusion. So which option is correct? Option 3 is correct. So if now I will be explaining sulfurous acid structure. So if you calculate the oxidation state here, for sulfur it will be plus 4. So if the oxidation state, calculated oxidation state is less than maximum, directly there is there is no peroxy linkages or something like that. Write the structure like this, sulfurous acid. So sulfuric acid structure will be like this. Like this. Already this is done. So if you find for this, you will be getting, listen to this, pyrosulfuric acid. So if you calculate this, 7 oxygens are there, so 7 to the 14, 2 hydrogens, so remove 2, it means 12. So we will be getting for each sulfur it is plus 6, done. So it is equals to maximum oxidation state. If it is maximum oxidation state equals to calculated oxidation state equals to maximum oxidation state, we will be having MOM type of bond. It means sulfur, sulfur right here, and the next oxygen here, oxygen here, oxygen here, oxygen here, next OH, OH, 6 oxygens are done, the remaining 7th one will be in between like this. I hope it is very clear without any confusions, right? Okay, important question for both NEET and EAPCET. So option 3 is the appropriate answer for this question. Next, alkene and ozonolysis. I just want to zoom this. Alkene and ozonolysis. An alkene and ozonolysis gives methanol as one of the product. Yes. If you break this, see, ozonolysis means wherever you are seeing a double bond like this, double bond is present. So just break that and insert oxygen atoms like this. C, C, O, this will be the carbonyl group, this side will be generating. If you apply same concept here, ozonolysis, the products formed is like this. See, on this carbon we have hydrogen, this side double bond is there, so insert a double bond oxygen, that's it. So this is the product, this side we will be getting acetaldehyde, but they are asking about methanol. Methanol the compound should be like this. Formaldehyde is a methanol here. Okay, so from which we can get, see, in option number 3 we can easily get. So if we break here oxygen, this side also one oxygen. So what is the material we are getting here? CHHO. This is called methanol. That's it. There is no option which provides methanol other than the third option. So only option number 3 is correct. I hope it is clear, no confusions. Next, from this, alkali metals and alkaline earth metals forms basic oxides, right? So barium oxide is there, so that is basic oxide. Okay, and non-metals like chlorine, like this, they will form chlorine, nitrogen, these things forms acidic oxides. So this is acidic oxide. Okay, now here we have Al2O3, so this will forms amphoteric oxide. Okay, so CO is neutral oxide, like this. So A2, the only one option is there. B1, yes. C4, yeah, only second option is there, so you can choose. So whatever the like nature of oxides, you know, follow that and answer this. Okay, so just go through your NCERT book or any of your college, school, like institute materials you can see, or otherwise in the videos I have made a periodic table video. Okay, so in that part 3 I think, so I have included what are the oxides and the nature. Okay, so at least you need to know that basic, what is the nature of those oxides, because we will be seeing this kind of questions more and more times, right? So this will be important again. Make the list of oxides. See here, see the metal ion activates many enzymes, participate in the oxidation of glucose, produce ATP with sodium. The responsible for transmission of nerve signal. So with sodium they are saying na, so it will be potassium for nerve signals. Okay, now see here in this methane the oxidation state will be, see, carbon is more electronegative than this hydrogen, therefore it will be having -4. So now it is converting into CCl4. Now chlorine is more electronegative than carbon, it will be converting into +4. So -4 to +4. This will be the change. That's it. Very easy questions are there, but we need to focus more. Like easy questions, need to know basic concepts first. That's it. Okay. The compound X in the following sequence. Okay. So here chlorination in presence of sunlight, free radical substitution mechanism, right? So here we have like this. So depending upon the product, we need to decide the X here. So whenever we are doing chlorination in presence of sunlight, it will be produces like chlorination at this carbon. Okay, here if they mention alcohol, remove only one hydrogen and write it as like this. Okay, because if the product is alcohol, this will be the X. If product is alcohol, that will be the X. Okay, if product is aldehyde, so it should be divinyl, I can say geminal dihalide, like this. So why it is like this? Because upon hydrolysis this chlorine is removed, on the same carbon we will be having CH, OH here and OH here. Now from this remove water molecule like this. So what is the remaining part? That is aldehyde only. So this is how the product is produced from X to the final product. So if in order to get this aldehyde, it should be what? A disubstituted product. So it should contain 2 chlorine atoms. Only option 3 is there. Okay. If we want if the product is given as carboxylic acid, so what is the X then? In that case, X will be CCl3. Try substituted. All hydrogens are replaced by chlorines, which upon hydrolysis removes all chlorines by OH minus, and upon dehydrating it will be producing carboxylic acid. So depending upon the product, we need to decide X here. That's it. So these are the questions of 2020 NEET exam paper. Okay, so if you have any confusions or any difficulties, and if you want any one particular topic to be discussed in the sessions, so you can write in the comment box, we will be discussing that. Okay, so we are there with you for your preparation. Okay, so now one more thing, I hope you really enjoyed the session. So if you really like the content, just share with your friends. Okay, so thank you for watching. Happy learning.